Grade 12s, we're on day 4 of sinusoidal functions and we get to graph today. So I can only model the way I think through these things because we're going to throw a few different features at a time and see how we handle it. So the first one, what I look at is that it's a sine. So I know what that looks like basically. So I'm going to draw my basic sine curve just to even get started. Sine always starts at 0, 0, goes up at 90, down at 270 at -1 and back. So my curve looks like this. I know that that curve goes on and on forever, so I should put an arrowhead. And going backwards, it would follow the same pattern, even in the negative angles of rotation. So I could draw my graph like that. So I've got my basic y equals sine x. Then my brain looks at all the different numbers that I've thrown into the equation and writes an English translation before I start graphing. So I would look at that x plus 60 in brackets and say, and there's supposed to be degree signs all over the place here, but there we are. And that tells me that's a translation because I'm adding a number. It's in the brackets with the x, so it's going to be a horizontal translation. And it's plus 60, and horizontal is weird, so it's going to be left 60. Then I notice the -2, and it's outside away from the x value, so that's going to be a vertical change. And because it's an add or subtract, it's also a translation, so that's from 2 days ago. And it is, as you think, it's down 2. So my two changes are left 60 and down 2. Then I can start to draw. I'm going to do it in two different parts. I'm going to do the left 60 first. So I'm going to take my entire function and I'm going to look for those key points just to make it easier. And I'm going to move all of those points over 60 degrees to the left. So each one of my squares on this particular grid paper is 45, so that's not quite as easy, but 60 degrees is 2/3 of, there we are. So that one goes to the left that way. That one goes that far, this far, this far, this far, and so on. So we've gone left 60 degrees, and my new graph will be there we are. So we've done the left 60. Now we're going to take that entire graph and move it down 2. So my new blue graph is going to be moved down 2. And I did something really silly on my scale here. Sorry about that. Down 2 would be 4 squares down. I'm just picking those same key points again. And where's this one? Here it is. 1, 2, 3, 4. So my grid paper may not be ideal, but I can see a function that has been moved down 2 and left 60. Let's try another one. Y equals sine x plus 45 minus a half. So the same thing's going on. I've got a sine wave curve. I have a horizontal translation, left 45, and I've got a vertical translation, down a half. This time, let's see if we can do those two things together. I'm going to start with my sine curve. Always starts at 0, 0, up at 90, 0, down to 70, 360, and it's going to have a mirror going left. So my basic sine wave does that. And continuing the pattern, there we are. There's y equals sine x. Now I have a horizontal translation left 45, which would be 1 square left, and down a half, which is 1 square down. So 1 square left, 1 square down. I'm picking each one of these points, and left, down, left, down, left, down, left, down, left, down, and there is my new curve. There we are. We have y equals sine x plus 45 minus a half. Okay, 1, 2, 3, 4 things going on. So we're going to step it up a notch. First thing I would do is draw a rough cos. So 1 minus 1. Cos starts at its maximum value of 1, and it goes back up to 1 again by the time you get to 360 degrees. So that is your basic cos curve at the lowest point in the middle. So and it would be mirror image on the other side. There. There is my basic y equals cos x. I'm going to go from left to right. So I'm going to have a big mess here by the time I'm done. The first thing I see is that negative. The -2 is a vertical because it's outside, away from the x, in front of the function. That 2 is a vertical stretch. That means the amplitude is now 2 instead of 1. And the negative is reflection in x-axis, which means it's upside down. I'm going to do that vertical change first. I always work left to right. So I'm going to have things upside down and double the amplitude. So instead of starting, let's watch my color here, instead of starting at 1 above 0, it's going to be 2 because the amplitude is 2, and it's going to be below 0. Everything's upside down. My zeros are the same, but if I'm supposed to be normally 1 below, I'm going to be 2 above. Everything's flipped. So I take those key points and I just see how they've been adjusted and follow along the curve from those key points. There we are, upside down, double the amplitude. My curve would look like that. So that's the first transformation that's gone on. The next one that I see is that number 4. Number 4 is in with the x, so to speak. So that's going to be a horizontal change. And it's going to be a horizontal compression a quarter, which is very strange. That means that the period has changed. It is no longer 360, but 360 divided by 4, which is 90. So that means you have an entire cycle, down, back up, back down again, in 90 degrees. So I'm going to draw that one. So I'm going to start at my y-intercept, and I've got to make it go up and back down again in 90 degrees. So I've got to go all the way back to here in that short of space. In the middle, I get my high, so my graph will do that. And again, in 2 squares. And so on. The next two things that I see are the 15 and the -1, and they are both translations from the first day that we looked at transformations. One is horizontal and one is vertical. I have a horizontal translation in brackets because it's close to the x value, left 15. Horizontal is always strange. Then I have a vertical translation at the end away from the x value, down 1. So I want to take my green function, move it left 15 and down 1. The down 1 is easy. The left 15 is left of a third of a square in this case. So down 1 square, left a third of a square. So I'm just taking some key points. Down 1, left a third of a square. 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 So that basically is my function. High, back to a low again. A high, back to a low again, using all of the transformations that I have. Okay, are you game for one more? This is where colors really come in handy. Y equals 4, sine a half, x minus 40 plus 3. 4 things going on. Again, I would model basic sine wave. So we are going to have 1 minus 1. Sine starts at 0, 0. It goes up at 90. There's a basic sine wave going the other way. It would be the same pattern. There we are. There's your basic sine wave. I always do that first before I do translations. Then I always work left to right. It avoids order of operations errors. First thing I see is that 4. It's out in front of the function like our a value. It is a vertical expansion. Sorry, you use the word stretch. Factor 4, which means that the amplitude is 4. There are no negatives, so it's not upside down. It's just changed the amplitude by 4. So it goes through 0, 0 still, but instead of a height of 1, it will be a height of 4. Back to 0. That one is easy because I'm not moving. It's the left and rights that are kind of tricky. There we are. The next thing that I see is inside the brackets. And I'm doing that one by itself. It is a horizontal. Everything horizontal is awkward. It is a horizontal expansion factor 2. And we know from these horizontal changes that it's going to change the period. And it's always 360 divided by that k value, which is a half, which will give us a period of 720. That means it takes twice as long to get where you usually got. So instead of taking 90 degrees to go from 0 to the highest value, it's going to take you 180. So my curve becomes this one. Oops. And it will become this. There we are. And the last two things that I see are the negative 40 and the positive 3. I like to do those two together because they're both just shifts up and to the right. So the minus 40 is a horizontal because it's with the x, horizontal translation. And since it's subtract 40, it's 40 to the right. and the 3 is a vertical translation, up 3, and I'm going to do those two things together. So I'm taking my green curve, 40 to the right is a little bit awkward. It would have been nice if it was 45, but it's not quite a square to the right, and up 3 squares. So we're going to be right off of the grid for this thing. So I've just marked in those key points, not quite a square to the right and up 3, and I will have the curve right through my writing. There we are. I have some for you to try, page 34.